This is the beginning of section 2.6, which is the last section of chapter 2, and it is about finding equations of lines and applications. And there are 5 objectives. Find an equation of a line when the slope and y-intercept are given. Second, find an equation of a line when the slope and a point are given. Then find an equation of a line when 2 points are given. Number 4, given the line and a point not on the given line, find an equation of the line parallel to the line and containing the point, and find an equation of the line perpendicular to the line and containing the point also. So more requirements. And then the last part is solve applied problems involving linear functions. So let's begin with exercise 1. A line has slope 3.4 and y-intercept 0, minus 8. Find an equation of the line. Well, if we start with the slope-intercept form of the equation, which is y equals mx plus b, we know that the slope is 3.4, so y equals 3.4x. And b is a y-intercept, with b being minus 8, so it's 3.4x minus 8. And that is an equation of the line. Passing through 0, minus 8, the y-intercept, and having a slope of 3.4. Now, the next definition is a point-slope equation. And that applies when a point and the slope is given, and we're supposed to determine the equation. So the point x sub 1, y sub 1. So in this case, the equation is y minus y sub 1 equals m times x minus x sub 1. So there are really 2 ways to do this, and I will explain both ways. Let's do exercise number 2. Exercise number 2 says we are given a slope of minus 5, so m equals minus 5. And the given point has coordinates minus 4 and 2. In other words, x sub 1 is negative 4, and y sub 1 is equal to 2. So using this formula here, we can write down the equation. So it's y minus y sub 1, and y sub 1 is 2, equals m times x minus x sub 1. And again, m is given as negative 5, so minus 5 times x minus x sub 1, and x sub 1 is negative 4, so we have to be careful with the minus signs. So we can rewrite this as y minus 2 equals, and now we use the distributive property, minus 5 times x is minus 5x. And we know that minus negative 4 is positive 4, so minus 5 times positive 4 is negative 20. Now we add 2 to both sides to isolate y. So y equals minus 5x, and if we add positive 2 to minus 20, we get minus 18. For exercise 3, we could use the same approach, but I want to show you a different way of doing this particular problem. We're going to start with the equation y equals mx plus b. Now we know the slope is equal to 3, so we can write this as y equals 3x plus b. Now is an important observation. The line passes through the point x equals 1, y equals negative 2. So in other words, now we're going to replace x with the number 1 and y with the number 2. So in other words, this now becomes y equals minus 2 equals, and again we have 3x, m is equal to 3, and x is equal to 1 times 1 plus b. So 3 times 1 is 3, we subtract 3 on both sides, so then b equals -5. So in other words, now our equation is equal to, there was plus b here, sorry about that. So now the equation reads, the solution is y equals 3x minus 5. So when it comes to exercise like 2 or 3, you can use either method. Use the point slope form of the equation, y minus y sub 1 equals m times x minus x sub 1, and substitute the appropriate values for y sub 1, m, and x sub 1. Or you can begin with the equation y equals mx plus b. We know what m is. In this example it was 3, and now we just need to determine what b is. Since the line passes through 1 minus 2, we can now substitute for y the number -2, and for x the number 1, and then solve for b. And so in this example now we have y equals 3x minus 5. And I would encourage you to use this method also, just to become fluent in it. And maybe for example number 2, use this method I used for number 3. See if you can interchange the method of doing it. You probably will find your favorite way of doing it. They're equivalent, obviously. So you just need to decide which one you like best. In the next exercise, we are asked to find an equation of a line when 2 points are given. So here we have 2 points, -3, -5, and -4, 12. So the strategy is like this. First of all, let's calculate the slope of the line going through these 2 points. And we know how to do that. We know that the slope is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And let's say this is point 2 and this is point 1. So then y sub 2 is equal to 12 minus y sub 1, which is -5. And then x sub 2 is -4, and minus x sub 1, so minus -3. So it gives us 12 plus 5, minus times the minus is plus, so 12 plus 5 is 17, and minus 4 plus 3 is -1, so the slope is -17. Okay. So now we can use what we just learned a moment ago. We can we have the slope and we have a point. In fact, we have 2 points. Which one of the 2 points should be used? Well, we could use either one. Personally, I like the one with the smaller numbers. The bigger the numbers, the easier it is to make mistakes. So let's say we use this as our point. So we begin with y equals mx plus b, where m is now -17, and our point is -3 and -5. Okay, so this will be the x value and the corresponding y value. So y equals -5, so we replace y with -5. That's equal to m, and m is equal to -17, times x, and x is -3, plus b. Of course, that's what we want to know. We want to know what b is. So we have minus 5 equals 51 plus b. We subtract 51 on both sides, so then b is equal to minus 56. So now we've got everything we need to know to write down the equation that we want. So y equals, again, m is equal to minus 17, so minus 17x. And then b is minus 56, minus 56. So you may go over this yourself, try it from scratch, and see if you come up with the same answer. Let's look at exercise number 8. Here we ask to find an equation of the line containing a point 2 comma minus 1, and that's in the line that's parallel to the given line 9x minus 3y equals 5. First of all, we need to find the slope of the given line to find a parallel line. So we rewrite the given equation 9x minus 3y equals 5 in slope-intercept form. So we subtract 9x on both sides and divide now by minus 3. So then y equals 3x minus 5/3. 5 divided by minus 3 is minus 5/3. So we know that the slope of this line, of the given line, is equal to 3. Now the line parallel to the given line must also have slope 3, since we're talking about parallel lines. So now we come to the point that we had a moment ago, where we have this slope, and we have a given point to which the line is going. The coordinates are 2 and minus 1. So we use the slope-intercept form of the line we're looking for, with y equals mx plus b, and we substitute 3 for m. We just determined that that's the slope, and 2 for x, that's the x coordinate, 2 for x, and minus 1 for y, that's the y coordinate. So then we have and solve for b. So minus 1 equals 3 times 2 plus b. So minus 1 equals 6 plus b. We subtract 6 on both sides. So b equals minus 7. And now we substitute 3 for m and minus 7 for b in the equation y equals mx plus b. So that means that y equals 3x plus negative 7. And we rewrite that as y equals 3x minus 7. If this went by a little fast, I understand. There's a lot of things that come together here. And so you may want to do this on your own. There are similar examples in the book. But at this point, you should be able to follow these examples. You just move it up that you can see. So let me go over it again. We have a line to begin with. It's 9x minus 3y equals 5. The first step is to determine what the slope is. So we write this in slope-intercept form, and we find that y equals 3x minus 5/3. So we know the slope is equal to 3. Since the line that we are supposed to determine is parallel, the new line will also have to have slope of 3. So we begin with y equals mx plus b, and it's going to the point 2 comma minus 1. So we substitute 3 for m for the slope, and we substitute 2 for x, and minus 1 for y. So it gives us minus 1 equals 3 times 2 plus b. That means minus 1 equals 6 plus b. We subtract 6 on both sides, so b equals negative 7. Substituting the values for m and b in the last equation, y equals mx plus b, then gives us y equals 3x plus minus 7, or simply y equals 3x minus 7 as a final answer. The next exercise asks us to find an equation of the line containing the point 5, 4, and which is perpendicular to the given line of 2x minus 4y equals 9. So the first thing we need to do is we need to determine the slope of the given line. So in other words, we need to solve this equation for y. So in other words, 2x minus 4y equals 9. We subtract 2x on both sides. So we get minus 4y equals minus 2x plus 9. Now we divide both sides by negative 4. That isolates y. And negative 2 divided by negative 4 is equal to 1/2 x. And 9 divided by minus 4 is minus 9/4. So in other words, the slope is equal to 1/2. Now the slope of a line that's perpendicular to the given line is the opposite of the reciprocal of 1/2. So the opposite would be minus 1/2, and the reciprocal of minus 1/2 is minus 2. So that is the slope of the line that's going to be perpendicular to the given line. That line contains the given point 5, 4. So using the point slope equation with m equals minus 2 and x equals 5 and y equals 4, x sub 1 equals 5 and y sub 1 equals 4, we now have y minus y sub 1, or y minus 4, equals negative 2, that's the slope, times x minus 5, x minus x sub 1. So then we use the distributive property. Minus 2 times x is minus 2x, and minus 2 times minus 5 is plus 10. And now to isolate y, we add 4 to both sides of the equation. So then y equals minus 2x plus 14. Let me go over the last part again. So we know that the line that's perpendicular to the given line has a slope of minus 2, going to the point 5, 4, and using the point slope equation y minus y sub 1 equals m times x minus x sub 1, we substitute minus 2 for m, and 5 for x sub 1, and 4 for y sub 1. So we have the equation y minus 4 equals minus 2 times x minus 5. Y minus 4 is using the distributive property on the right side. Minus 2 times x is minus 2x. And minus 2 times minus 5 is positive 10. So we have y minus 4 equals minus 2x plus 10. And the last step is we add 4 to both sides to isolate y. So now y equals minus 2x plus 14. So that's the line that satisfies the requirement to be perpendicular to the given line and passes through the point 5, 4. The last exercise is an application of linear functions. And here we have a cost of a service call. And for a service call, Belmont Heating and Air Conditioning charges a $65 trip fee and $80 per hour for labor. Formulate a linear function for the total cost of the service call C of t, where t is the length of the call in hours. And then graph the model, and then part C, use the model to determine the cost of a 2.5-hour service call. Okay, so what it says here is that the cost of a service call, C of t, is no matter what happens, you pay a $65 trip fee. So that's $65 for the trip. And then for every hour, that they charge $80. So $80 times the number of hours. So T is the number of hours. Okay? So that's the base fee, even if they come out and don't do anything. If that time is 0, you still owe $65 just for coming out. So we can rewrite that in slope-intercept form. C of t equals 80t plus 65. So we have that in slope-intercept form, where t is the length of the coil in hours. Now we're going to graph this equation, and we know that the c-intercept is 65. So that'll be somewhere here. And the slope is 80. So here's how I graphed the line. The y-intercept is 65, or the CFT-intercept is 65. So this point is 0,65. The other point I determined by saying, okay, let's say for 5 hours, that means that it would be $400, and 400 plus 65 is 465 on the vertical axis, and 5 hours here. So that's how I determined this point here, 5,465. It's just a straight line. Now notice a couple of things. Number one, the graph is only in the first quadrant. And the reason why is that time, of course, is only positive. It only goes in one direction. It's not negative time. And the same is with the cost. In other words, if we extended the line down below here, that wouldn't be realistic because we don't have negative time, we don't have negative cost. So in many application problems, probably most of them of this nature, we're only dealing with the first quadrant. So be careful not to draw the line past the vertical axis. In most cases, again, think about it if it makes sense to be out on the other side, but in the majority of the cases it doesn't. So now we have the graph, and now we're supposed to use the model to determine the cost for a 2.5-hour service call. So in other words, now for the C part, we substitute t equals 2.5 hours or 2.5 hours. So now we're asking what is C of 2.5? So we replace t with 2.5, so that's 80 times 2.5 plus $65. So the total would be, in this case, then, well, 80 times 2.5 would be 200 plus 65. So then the service call for 2.5 hours would be $265. Again, you may want to think about this on your own and see if you can do it on your own. And with all the information you've had so far, you should be able now to work with word problems of this nature. Again, if it doesn't work the first time, keep at it. It just takes practice to get good at word problems. Very few people are born with that ability, but with practice, you will get better. That's a guarantee. This concludes Chapter 2.